Hello and welcome back to the Math Mindset. Today I will be covering how to factor quadratics and extract solutions from them. This lesson will be a three-part video series in which we will be covering three different methods to factor quadratics. Here we're going to be covering the first method, which is just taking out a common factor. Now this common factor could be an integer or a variable term. So let's explore some examples. So let's say we have a quadratic like 3x squared plus 12x plus 21. And we want to factor it or simplify it. Now how would we go about doing that? Well, notice that we can take out a 3 from each term because all three terms are divisible by 3. So we can take out a 3 and we can divide each term by 3. So 3x squared divided by 3 is x squared. 12x divided by 3 is 4x. And 21 divided by 3 is 7. So we took this quadratic, took out a common factor, and we ended up simplifying with this. Now taking out a common factor can be useful for simplifying equations and solving equations in fractions as well. Now let's look at another example. Let's look at a quadratic like 2x squared plus 8x. Now what would be the common factor here? Well, notice each term shares an x, right? And each term is also divisible by 2. So we can take out a 2x. 2x squared divided by 2x squared, 2x squared divided by 2x is x. 8x divided by 2x is 4. So this would be our answer to the problem above. Now let's try simplifying expressions where taking out a common factor in such radical expressions is necessary. So let's try and simplify the expression 5x squared plus 25x divided by x plus 5. What is this equal to? Well, notice we can factor the numerator of the expression. So we can factor this as 5x because each term is divisible by x and 5. So we can factor out a 5x. And this is times x plus 5. Right, when we divide each term in the numerator by 5x, we get x and 5 respectively. And then we have to divide this by x plus 5. Aha! The numerator and the denominator share a common factor of x plus 5. So this just cancels. And this turns into 5x. And that's our answer for this example. Right. In order to find out how you can solve bigger quadratics and find the zeros with this technique and the other techniques that I'll be covering in the three-part lesson, stay tuned. In the meantime, check out this video, or if you have the time, check out that playlist. But don't forget to subscribe.